everyone. This is Juan Soto. I'm the chapter president of Access with SQL Server User Group at AccessUserGroups.org. Thank you for joining us this evening. We got a great presentation. Before we get started, I got just one major announcement for you guys. Microsoft Access team has released a wonderful update that will allow you to use the Access engine outside the distributable for Office 365. So those of you who in the past has to install the Access 2010 engine in order to import data to SQL Server with SQL Server Management Migration Assistant, you'll no longer need to do that. You'll be able to do that with the this new update. So I put the link in the comments there. Please check that out. I have not personally tested, so if you have tested already and it does work with SQL Server Migration Assistant, let me know. But I think Maria Barnes, you tried that, right? Is it working? I'm not sure if Maria can hear me. But Maria might chime in here and let us know. All right. So please check out that link I sent you. As always, we have the wonderful Susan Pine, who's the chapter coordinator. That will be your online moderator. Susan, say hi.
Good evening, everyone.
Back in our control room. I am in Denver today, tomorrow through Thursday. I'm seeing clients out here in Denver. A couple of weeks back, I was in California, also seeing clients, and just got a new client in Boston, so I'll be traveling around. Well, I love traveling. It's not so easy in the winter, though, but I love traveling because you really can't really have to see clients face to face, and so it's always experience for me to go see my clients and be able to interact with them and work on projects. There are some clients I've never seen throughout the year. In fact, one of my number one clients, I've never seen him. I could run into him on the street. I wouldn't know who he was. Spends quite a lot of money with my firm and haven't seen him at all. But for the most part, I like a point of seeing clients. All right, so we're in for a special treat tonight. Our presenter is Jacob Golden. He is a consultant in SQL Server. I met Jacob at the Dallas SQL Saturday meeting at SQLSaturday.com, SQLSaturday.com. And in fact, they have another, I believe, SQL Saturday coming up. So if you're in the Dallas region, please go check them out. And he was kind enough to come to my session where I talked about how to start your own consulting practice. And he has a ton of experience with SQL Server. In fact, the other day I was talking to one of my clients that I'll be meeting here in Denver. They went on and on about how great Jacob was, and the more they talked, the more prouder I got, and the bigger my chest grew. So thank you so much, Jacob, for that. We appreciate it. Welcome, Jacob.
Thank you very much.
So I told Jacob that we're mostly an Access group crowd here with some SQL Server experience. I always start my presentation by saying I'm not a SQL Server expert. I'm an expert in Access with SQL Server. And I asked Jacob to come on board and talk to us about optimization and query plans and some great knowledge and nuggets that we can all walk away with. So take it away, Jacob.
All right, thanks, Juan. So I'm kind of on the flip side. So I'm really good with SQL Server, but maybe not so great with Access. So at some points, if Juan, if you think that there's some tie-ins on how you can do things specifically in Access, feel free to jump in. And of course, if anybody has questions, feel free to write them in the chat, and we'll try to get to those as we go along. So tonight I'm going to just kind of talk about some of the development aspects of SQL Server, a little bit about kind of how performance interacts with indexing and all the different things I'm going to talk about a bit. There's a lot of content to get through, but I'm going to try to snorkel and not deep dive, if that makes sense. So we'll try to stay fairly surface level. I want you guys to walk away with not as important to understand the concept fully, but more to know it's out there, right? Google's our best friend. If I go over something, you can take a note. Hopefully we'll be able to share this with everybody afterward. Go to the slides and just take the concept and Google it and go, now I understand. I can read pages and pages and tons of blogs about a certain concept. So I will start with indexes because they're arguably the most performance-enhancing thing we can do to our database. Between writing.
Jacob, I just want to let
Sure.
you know, it looks like you're sharing two monitors, maybe. Because I have half of my screen blank and the other half is a PowerPoint.
Oh, I do have an ultra-wide monitor, so it doesn't really allow me to.
Oh, okay, all right, that's good. Okay, good.
But I
Well,
did
at least
try
we
to.
see it.
I tried to share just the application. I hope that
Yeah,
it's not too distracting.
Still to the side here. It's a little smaller, but we'll survive. Wait a second, something
Let me
happened.
see. If I do that, is it better?
No, you can. I think it was better the other way. That one, the other way where you had it when you first started out.
Okay. All right. Well, we'll go back to that then.
Oh, wait
All
a
right.
second, that's better. Now it's centralized. Okay, good. All right.
Okay. Perfect. All right. So it's like got an annotation request. I'm not sure what that's for WebEx. I'll hit approve and we'll see what happens. All right, so indexes. There's two basic types of indexes in SQL Server, clustered indexes and non-clustered indexes. The clustered index is basically the sorting of the table. It's kind of like the phone book. If we go from A to Z, it's easy to find and sort through the phone book to find what you're looking for. If you didn't have that, it'd be chaotic. So SQL Server, the optimizer, works in the same way. If we give a query, something like a select star from account to where the company ID is 109, just this here. If I say where customer ID is greater than 1,000, if I have a clustered index, I can seek all the way to 1,000 and start from there and go forward. If I didn't have the clustered index, it would be bouncing around through the table trying to find all the different pieces, and it'd have to scan every single record. So obviously, we don't want to scan every single record, and our clustered index helps us to do that. So it sorts everything. The cursor says annotating, and I can't get it away. Juan, are you familiar with the annotating? Never had to use this before. Let's see.
Could be that somebody requested to annotate. So
There we go. I got it. All right. So then the next one is a non-clustered index. Now the non-clustered index sits on top of the clustered index, so it remains sorted, but it's mostly used for actually covering a specific query. So you can see a case where over here on the left side, we've got the no non-clustered index. It's just the clustered index I created from before. And if we say where state equals Texas, it doesn't know what state is. It just is going to have to seek every single record, and it's going to scan through the clustered index in an ordered fashion on the customer ID because that's what we told it originally. If we look at adding non-clustered indexes, we now see that if we create an unclustered index on state, we're going to seek down to the information and we're going to find exactly where TX is in the state column, provide all those out of the non-clustered index. And I've just kind of highlighted, and I'll talk a little bit more about this stuff later, but our logical reads on a clustered index versus a non-clustered index, even just basically, a tiny little table, you can see the difference. And if you start to scale that out and really start to think about doing millions and billions of records, it can have a huge impact. So that's why I always tell all of my developers, the one thing is, yes, you need to write good code, but after that, after you've made sure that the code is good, work with a DBA or Google as much as you can to kind of understand how to create non-clustered indexes to cover your query, because that's where you're really going to get good performance.
Hey, Jacob, we have a situation where sometimes we build apps where we, instead of deleting the record, we just set a byte field to delete it, for example. And that way the record is still in the table. And we modify all our views and queries where deleted is false. Would that be something where we do a non-cluster index on, where we want to see only those records that don't have the flag?
Yeah, and I'll touch on this here in a few slides, but basically I'll show you how to build an index based on the parts of your query. So you'll know which parts actually make sense in the index and which don't. But yes, absolutely. So if you have that field, if it's a to delete field or something like that, then you would create a non-clustered index on the to delete field, and it'll help that delete run a little bit faster because the original data set that it's trying to pull out to delete will return faster. Yep. So before we get into I wanted to show you before we got too far, because we're going to be using some of the pieces from the statistics.io in time, just how you get those. So SQL Server provides two commands that you can either put in your code or you can use through Management Studio and set on the windows. So these are query level, and what it's going to do is it's going to help to show you how much work the SQL Server is doing to run your query, whether it's I/O or CPU time. And these are fairly easy to add to your code, and you'd only do it at kind of the time where you're trying to determine how it's going to run. You wouldn't do it all the time. So when we look at an example of creating an index, you can see over here on the right where it says the rows, CPU time, logical reads. That's the basic information you're going to get from the statistics IO and statistics time. Now, I've just got a couple examples here. So if we did a select customer ID, first name, last name from customer where state equals Texas, this is the same thing we showed earlier where the non-clustered index is not created, so we're pulling back from the clustered index. Now, to create a clustered index, you can only have one clustered index per table, so you want to make sure you kind of understand your patterns that your data is going to be pulled from. Right, so customer ID, if you know that that's going to be a where clause in every query going forward, or that you're going to join on it with other tables, then you would want to make that your clustered index and sort all of that data, right? And then when you go to create a non-clustered index to now cover this query, we can see down here, I've got a few things highlighted. And so when we create a non-clustered index, we do it on our where clause here. So we would say our non-clustered index is IX state on customer and state being the key. And then we're going to include all of the columns that are in the select statement to be included in the non-clustered index, but they won't be keys in the index. Now, I'll go a little bit further into this in a minute, but you can see as the query plans pull out from your actual query plan, we're now seeking the non-clustered index, which is giving us 143 logical reads and almost 0 CPU time to compile that statement. Whereas with our clustered index, we had 21,547 reads and 94 milliseconds of CPU time. So again, these numbers may seem small, but when you scale them up into millions of records or concurrency with hundreds of people trying to run the same thing at a time, you can really see where you can get some value out of adding non-clustered indexes to cover some of your queries. So this is a little bit better of an example of how you would determine what should go into your indexes if you're going to build indexes. Your index key, which would be that part here, where it was inside the bracket, little parentheses right after your table, is going to be anything that's in a where clause. So all of your where clause components should go into your key. And they really do have to go in order. So if your where clause has, say, run status tie equals 3 and customer ID equals 2, and so in your where clause, you would go from top to bottom and put those keys in order in your non-clustered index so that it can be reused. And then you try to write every other query that is going to also use that non-clustered index with the same sorting of your where clause. Because if you start to write where run status tie equals 3, and then you put order ID equals 2, and then you put your other columns, well, now you've changed the basic data in your key, so you're not even going to use your index. So important to just understand that when you're building your index, your keys are going to be everything in your where clause, and then your include statement is just going to be everything else. So everything in your select, everything in your joins, if you are doing joins to other tables, and things like that. So then you can kind of see here, I've created this where run status tie is my key, and then I've included run ID, period tie as my include, just based on what I see up here. And again, we'll see, index seeks, which is typically, on average, what we're going to want to see, right? So if we start to see anything with the word scan when we're running an execution plan, which we'll talk about a little bit later, we want to try to get rid of the scans and you typically always see seeks. And we can see again, kind of the basic reduction in reads and things like that, because our overall goal from a SQL Server perspective is to always pull everything from memory and really never have to hit the disk. So the fewer logical reads we can possibly do on a query, the better. And that'll be from that, statistics IO and statistics time set earlier.
Hey, Jacob,
most
of the developers on this call will probably use the query index suggestion that comes up when you press Control L
Sure.
to analyze your queries. What do you call that when you press Control? What is that process that analyzes to see if you can get an index?
Yeah, and that's where we're actually going to go into next is execution plans. So when you run an estimated execution plan, basically you're hitting this little button here in your Management Studio. And if it has a missing index, it would come up and show you that. And that would be similar to what you see here. Missing index, impact. Now, these are fairly good representations of what the optimizer thinks it should need from you. What you always want to be careful about is that the more indexes you put on a table, the more impact it's going to have on updatability. So when I say that, I mean inserts, updates, deletes will all have some kind of impact on having too many indexes on your table. Whether that means that the indexes, the inserts, deletes, and updates are really, really slow, or it could be that they even lock the table depending on a lot of different factors. But your select statements should be much faster because they're covered by your indexes. So it's a little bit of a balancing game. And so when you see one of these missing index recommendations, you don't necessarily always want to just go at it. What I would typically do is open the table in Management Studio and then navigate down to the indexes. And if they're named in a way that tells you what the keys are, then you can quickly scan through those and see that. If not, just open every one of the indexes and just see, the columns that it's recommending. Say this one is recommending state. If you already have an index with state, then you don't want to recreate it. What you want to do is just add these columns, customer ID, first name, and last name, into the include part of the index. And that way you can keep reusing existing indexes and not double up and triple up and have duplicates. That kind of makes sense.
So some queries that might have additional fields in the word clause, you're saying that you're better off just adding to the existing index, even though that index, that particular query may not have all those fields they'll use in the index.
Yeah, so again, it would depend on your where clause. So if your where clause goes in an order that follows the keys of the existing index, then you could just add things into the include. I always try to make sure that if you're going to add additional keys into an index, you add them at the end and not anywhere at the beginning or in the middle of the existing keys structure, because that changes the already positive impact that that index is having on some other query that you may not know about. And it may now start going to the clustered index because you've changed the keys that were in this index. So this is what I usually tell my DBAs, is to always add to the end of an index. If you can't, because it's going to change too much, then just create another one. It's okay to have duplicates. You just want to be careful that you don't have a lot of duplicates. So, are there any other questions before I get too far? We'll start with indexes.
We had a Greg ask about what about creating indexes on views? I've never created indexes on views. I always create them on tables, but can you create an index just on the view?
Yeah, so you can create indexed views. The thing you have to be careful with is that you do have to schema bind the views, which means that you can't change the underlying objects from that point forward unless you drop the view. So the thing that you want to do is make sure that if you're going to have future development on that table where, say, in the middle of the day, you want to be able to add a column to the end of that table because you have some new piece of data you want to add, you're going to need to script out the view, drop it, add your changes to your table, and then recreate your view. That's the only way to be able to actually change the underlying tables. And of course, if you have 7 or 8 tables all joined together in that view, then of course you're going to have to take that view off and do all the different tables underneath. So it could be very advantageous from a performance perspective. Somebody's asking, or Greg's asking, what's the advantage of an index on a view? So sometimes you have tables that you're joining that have millions and millions of records in them. And it's going to take a long time, but you need the view for the business logic, right? Well, if you put the index and you schema bind the view actually kind of takes the place of tables, right? It feels like you put everything that you wanted to join into a temp table, and that now you're accessing that temp table, but that temp table has been indexed, if that kind of makes sense. So you're materializing the data from the view from the underlying tables.
All right, thank you.
Sure. All right, let's see. We'll go into execution plans. So once you've added your index, how do you know if it's being used? How do you know if it's any better? The two things that I always look for from a performance perspective is first, starting that statistics IO and time on my query window so that I can capture how many IO I'm doing in my CPU. The second thing I do is I press this button here, which is the actual execution plan. So you can run the estimated execution plan without actually running the query. And that will tell you some basic information, kind of like you would see here, where it will show you the different tables being accessed, what indexes are being hit. But when the optimizer goes to actually run the query, it can actually create a different plan than the one you thought you were going to use based on the estimated execution plans, because things may have changed, or the data distribution may be different, or you may be using some things in the code that it just doesn't understand quite well, temp variable tables and things like that. So running the actual execution plan and actually being able to run the query, execute it, will give you your actual execution plan. So if we just kind of look at the basics here, your clustered index scan is what we call an operator. So in a execution plan, every one of these little kind of boxes with an icon and some information is an operator, and it's trying to tell you some piece of information that is going to be impactful in the query. So in this case, where pay rank ID equals 50 is not a non-clustered index currently, so it's having to go scan the clustered index, which means that we're basically checking every single record in that table, and so we're generating a lot of reads. So as I get to the end of this, I'll have kind of a little sheet that shows all of the things that you see and you go, oh, I don't want those in my query plan. This would be the top one. You don't ever really want to do a clustered index scan if you can help it. Clustered index seek is just a little bit better, which means that I'm at least telling SQL Server to use the entire clustered key, and I'm doing it in a way that allows it to seek down the clustered index based on its natural ordering. So whether that's ascending, customer ID, or whatever. It's a little bit better, obviously. So we went from 2,500 reads to 3 reads because it knows, just like the phone book, go to the S's, or go to the 1788 company ID and go customer 1 and pick out that one record. Next one would be an index scan on a non-clustered index. So just because we've built out what we think might be a good non-clustered index may still need some other things, like maybe we forgot to put our customer ID and rank ID into the include statement, and all we did was add pay rank ID as the key in our non-clustered index. Well, it's good, it's okay. It gets us down to pay rank IDs of 50, but then it has to go back to the clustered index and get not the clustered customer ID and the rank ID because we didn't provide them in the include statement. So still better than a clustered index scan, but not quite as good as the clustered index seek because we're telling it exactly where to go to get the data. So then the last one being the index seek. This is what we typically want to try to get to, right? We're giving it every piece of information it could need. We're saying our key is pay rank ID. We're going to include the rank ID. The customer ID, you may be asking yourself, wait a minute, you didn't include it in the include statement. Why is it doing a seek? Well, the customer ID is already part of the clustered index. So, you don't actually have to put it into your include statement, but I do it just for readability purposes. When somebody else comes in and tries to start, you're doing a little performance tuning, you can see exactly what is in the non-clustered index. So this gets us down to even better than the clustered seek, right? It tells us we're going to only do 2 reads. We're going to get the 2 records that belong to this pay rank ID, etc. And this is kind of, in the end, as we scanning down, this is where we kind of want to end up. Does that kind of all make sense?
Yeah, what you're saying, the index is what we should try for. So when we look at the execution plan, where in the execution plan does it say index seek? At the very top where it says optimize index for query?
So I probably should have had a management studio that I could pull up and kind of walk through. If you click on, the estimated or actual execution plan, and you get this kind of really long bar of stuff, that's kind of where it's going to show you. So it'll have the different icons with index seeks or index scans and a bunch of other stuff. So that's kind of where you're looking in the execution plan. It'll show you the little icons that say index seek.
Okay, it does say index seek. I'm sorry. Yeah. Hey, so we got a question from Ben. He wants to know if index will improve sorting on views.
So it wasn't a question, it was more of a statement.
No,
yes,
they're wondering
yes,
if-
indexing.
Yeah, if indexing will help when you sort on views in the query.
Oh, yes. So there's 2 layers to a view. There's what you see in the view definition, which would be, 2 tables joined or something, and some business logic and a where statement. And then the other is how you use the view in your actual code. So you may be joining to that view, and then you're doing a where statement, which has some of the components of the view and some of the components of your now query. So you actually need to index to both levels of that. One, you need your view to be as performant as it can be without any additional filtering. So you'd want to basically create filters or non-clustered indexes on your where clause or any joins in your view itself. And then outside of that, in your actual code that uses the view, you would also want to do any non-clustered indexes that combine the code from your code and your view's code. So it's a little bit of a daunting process to kind of go through, but execution plans, the estimated execution plan button will help you all the way through that. So you start in your view, estimated execution plan, work out the correct indexes for it, go the layer up into your code where you're joining to that view, and then do it again. Estimated execution plan, look through all the different operators, see what's an issue. Right here on the screen where it has this little select with the kind of yield icon. Anytime you see this little yellow exclamation point, it means that there's some kind of an issue in this plan. And the good thing about the estimated execution plans or the actual execution plan is you can hover over these operators and it gives you more information. So if you hover over this select in Management Studio, it would typically say, you're trying to write a query that has a implicit conversion. So what that means is you said it should be an int. Well, you're joining it against an varchar. So those 2 data types, while they are compatible, it has to do a conversion of the data so that they match evenly on the back end inside of SQL Server. So if you're doing that in the where clause, it can be problematic because the optimizer looks at it and goes, well, I'm going to have to do this later. I can't do it right now when I'm trying to compile the execution plan. I'll have to just do it as part of runtime. So it may not create the best plan. it may not create a plan that uses the indexes you think it should use. So if you're creating indexes and you go, I just don't understand why it keeps going back to the clustered index, but you see this little yellow exclamation point, just hover over it and it'll kind of tell you what the problem is. And then once you've corrected that, say you did a declare of some variables and you told it in varchar, but it should have been int. Well, if you cast that variable into a different data type up at the very top in your set statement or something like that, so that when it gets down into the query they match, then you should get rid of that little exclamation point and probably will see your indexes line up. So there's a lot of little things you can get from the execution plan that'll be very helpful if you just kind of highlight and hover over things.
Okay, thank you.
And so this is kind of what I was talking about. When you highlight over one of the operators and you hit F4, or if you already have it open, the properties window, it's going to show you a bunch of stuff. It'll show you the number of executions that it thinks it's going to have to run through to get your data. So if you're using cursors or something, you may see executions be higher, while loops, things like that. Number of rows it thinks it's going to have to go through to be read, so 17,515. Number of rows it thinks it's going to come back with based on your query. What the operator cost is. So if there were clustered index and then 4 other non-clustered indexes, it's going to kind of cost out each one of them and try to get to 100%. So this one may be 20%, 10%, 10%, 60% or something like that. And all of that will show here. It'll also show if the ordering of the data is being followed in your query. Since we're using PayRank ID and the clustered index is not on PayRank ID, it's not even going to use the ordering of the table from my query's perspective because it doesn't know what PayRank ID is in the clustered index. So, and then table cardinality is just a fancy term for how many unique rows are there in this all table. If there's 100,000 records, but there's really only 17,515 unique records, the table cardinality in your hovering over and clicking on to come into your properties of your operator will show you what the real unique cardinality is essentially. Right? So this is still an estimate. We haven't run the query yet. Same thing with the index seek, and you can kind of see the differences a little bit here. Once I've added my non-clustered index and we know it's covered, PayRank ID and the key, so now you see estimated number of rows to be read is actually 48. So this is the same query. I just added a non-clustered index to cover it. Well, so now the optimizer goes, wait, I know how many there should be because we've already got an index on this. 48 records, this is how many I want. And now I'm actually ordering it because my PayRank ID in my non-clustered index is ordered. Because you either give it a ascending or descending. So you can kind of see that the cost difference and the way that this structures out is much better. And you can kind of see all of those different pieces of really valuable data. And then lastly on execution plans is these are kind of the the basics of the cringeworthy operators to look out for. Table scans, that's definitely the worst. That's the worst thing you can see typically. There's never and always a never in SQL Server. So sometimes there's going to be little 10 records, something like that, and table scans are completely fine. But on the average, I would never want to see a table scan in my operators. Sorts, if you can not sort the data in your query, if you can do it outside in your application layer, your web layer, or something like that, it's always better for SQL Server to not have to order the data. And that would just be the order by, at the bottom of your query. Yeah, go ahead.
I got a couple of questions. Maria wants to know if there are tools that you can use that are better than ones in SQL Server to analyze and determine if indexes are needed.
Yes. Trying to think. Century 1 Plan Explorer. So they changed their name. But yeah, Century 1 Plan Explorer is a free tool. It's extremely good. You can install it on your local machine, wherever you have access through Management Studio. And you can export the plan into Plan Explorer And it actually does plug in with Management Studio, so I think you can even right-click on the execution plan and say open with Plan Explorer. But it will give you better color coding. You can sort all of your commands that are in the execution plan to see which one is causing the issue. So yeah, that is one thing that I would get probably for most of my developers is Century One Plan Explorer, because it's free and it does a really great job. Most of the MVPs in the SQL community would use it if they were wanting to really deep dive an execution plan. And there are tons of others, but that's the one that I know is free and works really well.
So regarding indexes, James wants to know, will encrypted column indexes be an issue? For example, Social Security number is encrypted. Does that carry a burden on the index?
Yeah. So yes, encryption does strange things to the optimizer. Basically, you're indexing a var binary piece of data at that point. You're not actually indexing the Social Security number. So you end up having to write queries that understand the var binary equivalent of the data instead of the actual SSN in order to use the index properly. So it's a little tricky. Something that advanced, I would really Google around and find the right recommendations. I haven't had to deal with it in about 6 years, so it's not off the top of my mind. But yeah, it does definitely become problematic. I have 5,000 rows being returned by view to populate a list box. Is it better to sort the list on the server or the client? My preference is always to sort on the client. Juan, I don't know if you have any recommendations, because I'm sure there's some point of diminishing return in doing it in the application layer. But
so if you try to create a view, right, views won't let you save with a sort option. So an order by, you can't save. Right. But look, if you're finding that you've got only 5,000 rows, I really don't think you would have a problem sorting in Access. But you want to also see if the list is if it's a table that doesn't change much. I usually end up doing local table and then synchronizing with the server, just because I don't want those round trips with the server to go read a 5,000 row table.
Yeah, and I mean, if it's a 5,000 row table, yeah, sort all day, no big deal. If it's a 50 million record table and you're pulling 5,000 rows out of it to return back to the client, then I would probably not do a sort or order by in SQL Server, because it's ordering, after having read all 50 million records or whatever. And so, yeah, the ordering can definitely have an impact on which index gets used and how when you're talking about data sets like that.
So Ben just corrected me. You can sort on a view if you do the top. Select top 1, 2, 3, 4, 5, 6, 7, 8, 9, and views in order.
Yeah. All right. I'm going to just move on to these are kind of quick hit nuggets, like you said. So Codon Syntax. First thing is joins. In Access, it's an easier situation because it's a visual system. You can write them, but from a user's perspective, they find it easy to do the joins. They are basically the same thing in SQL Server, with a few exceptions. There are a few additional things. So inner joins, every row needs to match between the left and right. So selecting from customer, inner join on customer type, it's only going to give you all the records from both tables where they match. Left outer joins, each row from the left table will be returned regardless of whether they're in the right. A right join, and I've kind of got some examples here. And so if you look at customer left join on customer type, it's actually the exact same thing as a right join where we've reversed the tables. Customer type, right join to customer. So if we just reverse these, you can interchange. And I liked this when I saw it. Somebody said, "Isn't that kind of obvious?" And everybody went, "Not really." So if you're using a right join And you're like, well, it always gets confusing. If you reverse the order of the tables, you can basically just use a left join. Full joins return all rows from the left and the right, whether they have matches on data or not. So if you are doing a full join, if it does match, you'll get the record all the way across the row. If not, it'll just give you whatever doesn't match from the left and also whatever doesn't match from the right, and then nulls in the rest of the fields. So it can be problematic to use that if you have massive, massive tables. So just make sure you know kind of what you're looking for when you use something like that. Cross joins, I think, are a SQL Server only kind of thing compared to in Access. Cross join, cross apply will allow you to take everything from the left table. So in this case, select customer ID from customer, and then you're going to cross apply it to something that gets a data set. So in this case, I'm using, say, a function. So if I have a little function written that's get orders and it takes a customer ID in, then I could say I want everything from customers cross applied against this get orders function on, joined on the customer ID. And then it will run everything in the customers table. If there's 1,000 records, it'll run one record at a time through this function, apply the get orders data, and return back your data set. So I think that's kind of handy if you're kind of doing lookups and things like that. Outer join returns all rows from the left table. So it's kind of, obviously, I was thinking of an outer apply. Returns all the rows from the left table. It's kind of similar to a left outer join. So an outer apply will do the same kind of thing. Union and union all, those aren't necessarily joins, but they kind of join two disparate data sets as long as all of the columns are the same. So a union, you might write select star from orders, union, select star from orders 2, something like that. So basically union will give you only the non-duplicate data. So it's going to dedupe the entire data set between the two and give you back the data. A union all will give you everything. It doesn't care about duplicates. It's just going to give you both data sets stacked. I find it better to do a union all and then wrap the entire thing and do a distinct or something like that. But it's up to how the execution plan turns out. And I always say everything you do, test it, right, to find the best method. And then the one that I found most interesting from a code perspective is pivot. In Excel, it's easy to pivot a data set. Columns turn into rows, and etc. So you can do the same kind of thing in a pivot statement. They're a little complex, so I always Google and try to watch from an example or something like that. But it basically allows you to kind of do that same thing where you're pivoting your data. So say you've got a bunch of employees and you want to do a pivot on their total salaries across a group or something like that. So pivot is kind of one of my more favorite kind of join syntaxes. Any questions on any of those before we go on?
I have a question regarding the joins in a view. Mm-hmm. Is it true that you're not supposed to mix match and have too many different join types in a view? Is it best to stick to say if you're doing left, don't include, don't do right as well. Keep them all left.
Well, from a left and right perspective, it's really kind of preference because, like I said, you can always kind of rearrange your tables to do the lefts and the rights. But from a precedence standpoint, I would say the thing that I focus on is making sure I get all my inners first, and then put any lefts or outers or rights at the bottom, because you do get some. I forget what they call it. If you do the tables with the fewest amount of rows, it's going to narrow down your data set in the top in your inner joins. You're going to have fewer things to have to join onto the left join or right join. So when you're doing a left join on your filtered down data set, it basically is having to do kind of a match of every record. So you're scanning that right table in your left join a bunch of times. So that's my kind of takeaway on intermixing different join types, is just to do the ones that will narrow down your data set first, and then do the things that need to be scanned based on that data set at the bottom of the join set.
Okay, thank you.
Yeah, and Ben was mentioning unpivot as well. So yeah, I didn't put that there only because I think I forgot to put it on there, but I've never really used it. I always pivot. But yeah, unpivot is also available as well. How about including something like field 1 equal 1 in join versus where clause? Is there a difference? There can be a difference. I have seen where doing your filtering in your join statements can actually create different results. And I think it's, again, due to the precedence, how it goes from top to bottom in your join clause. So you may be eliminating a piece of data in your earlier joins that a later join needed in order for it to be accurate from a business functionality perspective, right? From a business rules perspective. So it is fine to do it. Just be conscious of the order in which you do your joins so that you're not eliminating data too early in the process of your joins. But from a performance standpoint, there's really no difference. The optimizer at this point knows well enough that you mean for it to be a filter, and it kind of in the background will take that field 1 and move it down into the where clause on its own, only if it wasn't meant for elimination. So it kind of does some of that stuff for you. Okay, I'm going to move to case statements. If you've never used a case statement, I think they're one of the better things in SQL. So case statements allow us to do what would be equivalent to kind of if-then scenarios in our select statement, like inline if statements. So I've just kind of built out a couple of examples. So select customer ID, and then I'm going to say I want to count the customer IDs or the customer types where they only match certain types, right? So if I have customer types of 1, 2, 3, 4, 5, and I only want to count records if they're a 1 or a 2, then what I can do is say, or I'm sorry, in this case it's a 1. So I say case where when the customer type equals 1, then 1, because I'm going to do a count. So I'm going to count 1s over and over again for that. But when it's a 2, then 0. So I really don't want to count those, but I also don't want 3s, 4s, 5s, 6s, 7s, 8s. So I'm constraining myself in my case statement, and then so I get to count. So I get customer ID grouped, and then the counts of the records of, the counts of 1 were customer type. And then, so filtering out zeros, you can also do the case statement in your having. So at this point, I'm saying the same exact thing, except that I only want those that are greater than 0. So if I had a customer ID with 0 count of my customer type description, then I would want to filter those out and not even show them on my data set. So in my having statement, after my group by, I could put the exact same thing I had up here, down here, and just say greater than 0 to filter out any zeros that may come back in this case statement. And that's just to show you that you can use it in multiple places. You can use it in your select, you can use it in your joins, you can use it in your where clause, and you can have it in your having clause, and in your ordering clause as well, matter of fact. So case statements are really nice. They can be used kind of everywhere. And then you can also use it to change a data set on the fly. So in this case, what I'm saying is if the customer type equals 1, then I want to give back consumer as a piece of text, right? But if it equals 2, then I want to say business. And so where we're only storing an int in the database, I can now say I want to bring back customer ID and a piece of text with a description of what that data type is as opposed to the 1s and 2s, which may not mean anything to anybody. So it's good to be able to change values on the fly in your code easily, right? Any questions on that?
Yep, this is question. When you're doing a group by, what is the difference between doing a where and a having?
Having is basically filtering out your grouped data, where a where clause will be higher in precedence. So it will happen before your group by. So it really depends on what your intent is and if you're using any kind of aggregation. So having group by and having must be on the table, the query, if you've got a non-aggregated field mixed with aggregated fields. So really your having is kind of if you're doing aggregations and you want to kind of filter on those aggregations.
Okay, thank you.
Okay, so exists and non-exists. A lot of times in kind of older school code that I was developing, there was this need to do a subset of data. And so what we would do is we would do select from where customer ID in, and then we do another subselect that filters what customer IDs I'm going to return back to my query. Very slow. The indexes aren't used appropriately typically. The optimizer just overall doesn't like them very well because it's having to scan two disparate data sets according to it. So if we use exists, it doesn't check for every single record to exist. It just says if it exists one time, the first time I see it, I'm going to count it as a yes. So as I'm going through and I say where customer ID equal customer ID, blah, 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 it says, okay, well, there's 1,000 records with customer ID 1. I don't care that there's 1,000. I see it one time, I'm going for it. And so it'll bring it into your data set. So it's much more performant and efficient from an optimizer perspective using exists. As long as you're not doing aggregations on the data that you're joining to, because you still are going to get elimination of data using exists as opposed to the in statement. And similarly, not exists is basically exactly the opposite of that, right? So you want to make sure that you're capturing country where it does not exist in this other data set. So it's good both ways. Exists. Are you saying that it short circuits? I'm not sure what the definition of short circuiting is in this particular instance, but I would say read up on the difference between exists and in a where clause, and it'll kind of just tell you a little bit more about what specific scenarios can give you bad data sets. So if you're doing, like I said, kind of pulling out aggregations of how many records were in this subselect, and you're going to bring that in as a piece of aggregated data, that will definitely give you wrong results if you're using exists, because it's only looking for the first time it sees a match on those records.
It's about, instead of using a where exists, could you not use a CTE and then do an inner join?
Yes, absolutely. So
would that be a better performance?
It depends, and that's kind of the answer in a lot of scenarios. A lot of things just depend on your version of SQL, what your compatibility level is, and what the optimizer sees as far as indexes and everything else. So the best case for me, every time I'm going to develop a piece of code, is to write it both ways. I write it where exists, and I also write it in a CTE, and then I look at the performance, make sure that they gave me back the same data set. And then if I need an index, I'll put it in and look at it again between the two, and whichever one gives me the best is really what I end up using.
Okay.
All right, so kind of along the same lines as the exists and in and CTE concept is accept and intersect. So I really like these because you can tell it to give you a data set except where it's in another data set. So if I'm looking at, say, orders and order detail, and they both have the order ID column, I would say I want everything from the orders table except where it is also in the orders detail table, right? Very simple to write, very simple to read. So it's kind of like code reduction, right? Kind of concept. In the background, I'm sure it's doing the same kinds of things, right? It's using an exists statement, or it's using an in, where in, or something like that, depending on which way the optimizer feels is best for its performance. But for us to read it and write it, it's much better, right? And on the opposite side of that spectrum, we can use intersect. Now I'm saying I want order IDs where they also exist in order detail. So this is kind of like an inner join type scenario, but maybe a little more elegant because you can write two fully formed data sets that are going to be intersected on whatever column. The basic rules for these is that the two need to have the same number of columns, same ordering to those columns, not in the table structures, but in your query, right? So you need to have order ID, comma, first name, last name, whatever, in both your data sets, and they need to be in the same order in the select statement. And your data types need to be compatible. So you couldn't say, give me one that's date, time, and then one that's int, because they are not compatible. You would have to cast or convert in some way those two, which you could also do. But in the end, when they line up as a full data set, you would need to at least have those data set types be the same. So I've got a little example on that really kind of goes into how to use those as well. And I think this might be it's next to last slide. If you're doing web development is really where this comes in handy, or if you're doing maybe, I was gonna say drop downs, but kind of not really. This is really for paginating things. So offset fetch is something I give to all the web developers. And I say, if you're pulling in data into a grid, there's no reason to pull 1 million records into a grid. Nobody's ever going to be able to scroll through 1 million records. So what's your max data set size that you can fit into a screen? 50 rows, 20 rows, whatever it is. So offset fetch allows us to basically paginate our data sets. And so we use that after we have to order our data set because we need to be able to tell it how many rows to go in. We say offset at the beginning, 0 rows. So start with row 1, fetch the next 50 rows only. So that gives us 50 rows. And then the next time we want to go and paginate, we say offset 50 rows, fetch next 50 rows. So that gives us 51 through 100. So then how do we do this in a more efficient way, right? So dynamically, we can declare the offset, and the next, we give it whatever numbers we want, and we can pass those variables into our offset and our fetched. Cool. So that's really great if you're going to do compiled statements that are going to be sent into SQL, right? Well, what if we need to do it inside of SQL and just return the data set, and we're just going to provide parameters? Stored procs. Stored procedures are a way that we can have a precompiled set of code that lives inside of SQL Server and runs there as opposed to trying to stream the data, right? So if we have a stored proc, we can give it two things at the beginning that are parameters, the offset and the next. We just give it a name. So in this case, USP, user stored procedure, get customer info offset as, and then it's the same query we used, but giving it the parameter names here. And then in your code, execute, exec, stored proc name, and then whatever variables you want, right? So all we have to pass in, you don't even have to give them these as long as you put them in the same order that they're in the declare up here. So execute stored procedure name 150. Goes in 100, gives us 101 through 150. Does that all make sense? Any questions on that? I know those were a couple concepts in one, but
Yeah, I think we're pretty good at the stored procedure stuff. What we do have is James. We have a quick question. In a dynamically updated table, how would fetch handle new records that we just added to the page?
So every time you run this, it's going to pull the new data set. It doesn't cache it in the background waiting for you to pull the next 50, next 100. So as long as, I would say it all depends on your serialization or your, if you're using, read, I'm losing the concept now.
Okay.
Read committed, recommitted, snapshot, read not committed. I can't remember the term off the top of my head now all of a sudden. But yeah, as long as your data is committed in there, if you've added 50 records or a new record or something like that, every time you page, it's going to include that new record because it's pulling the next 50 of a new data set, not your cached original data set.
So it's good for high transaction environments, right? E-commerce sites have a lot of orders coming in all the time.
Sure. Sort procs for sure, absolutely. The offset fetch is more just to pagenet large data sets.
Right. Which is not the case usually with Access developers. We rarely see multi-million data record sets in our database application because we're coming from Access, and Access can't handle much data, right? If the client had a big database to begin with, they would have started with SQL Server already, with Oracle or a large .NET app.
Sure.
But it's hard for us to. Although I've had clients like insurance companies with 1 million+ records in their tables, this would have been much better back those 10 years ago when I was doing that. But yeah, I love what I hear so far, and we also store procedure. We pretty much have a good grasp on store procedure. So let's go ahead and go to the next point.
Good. So the last one is just a couple of helpful resources. Execution plans and indexes are very, we did a high-level touch on them. But if you go to this link, it's a very good blog. The person spent a lot of time really explaining how everything works. So I would say go read that when you have time. SQL Server Central is a really good resource. It's a forum that developers will go and ask questions. It's hosted by Redgate. As well as Stack Exchange. So if you have any SQL Server related questions, those two environments are amazing. And of course, we're always here if you have questions. So that's it for me tonight, unless there's more questions.
Can we talk a little bit about my fetch? Ben was asking about how we can use fetch and access.
So if you're using what is it, maybe .NET code or something like that. I'm not sure what is accessible in Access, but you would kind of write your T-SQL, SQL Server T-SQL statements in that to use your offsets fetch probably.
Okay. All right, good. So great job. This is where we open it for more questions. If you have it, you had a lot of praise, by the way, from the crowd.
Oh, thank you very much, everyone.
Yeah, 20 people on the call, which is awesome.
I've just unmuted everyone in case anybody has anything to say.
All right, now's your chance to ask Jacob.
How does SQL Server know which index applies to which query and view? It doesn't necessarily care which index applies to any specific view or query. The optimizer just looks at it as an entirely open spectrum, right? So every index could apply to any query, to any view, as long as it's crafted properly. But yeah, the optimizer is extremely smart. It's a black box. No one knows how it does its magic. We try our best, but yeah, even Bob Ward, who actually helps to create these things, is kind of mystified sometimes at some of the selections that it makes. PowerPoint link. So PowerPoint link, I'm going to resend this edited copy back to Susan, and then hopefully they'll be able to post it out for you.
usually post a link when we do the video on YouTube.
Could you comment a bit more on bit field indexes for non-distributed values?
Referring back to James to the example I did where you use a flag to see if it indicate the record was deleted in the table.
So I think it kind of is the same concept as the original kind of discussion about non-clustered indexes. So if your bit field is to delete, say, you would just create a non-clustered index on the to delete field, and that would be it. Because what you're in essence doing is you're saying, I'm going to select, create a selected data set of those to delete fields or deletion. So in any query that's a delete, the first thing it does is I select against the table to actually find what's going to be deleted, and then it does the delete. So your index on the bit field is definitely helpful to have a non-clustered index on those values to help it at least understand what's going to be deleted. Now, it may slow down your deletes because, again, the trade-off for every non-clustered index is that it has its impact on deletes, inserts, and updates. So you just have to be a little bit careful, but one bit field in a non-clustered index should be fine.
And honestly, I usually stay away from that kind of scenarios of using a bit field with marked records deleted. But I've told clients in the past is if you want to, we can just move the record to a duplicate table. That way it'll hold just deleted records, right? So the table is called customers. Then I might just call the deleted query table records customers underscore deleted customers underscore D.
Mm-hmm. And in those cases, having the non-clustered index will also help the select to move that table into an archive table, right? So.
All right. Any other questions, guys, before we go?
Oh, okay. So description mentioned performance differences between different versions of SQL. So I'll leave MySQL out of this only a little bit because it's not an environment that I touch much. So I'm not sure what the performance differences are there. But from a SQL Server perspective, I know that there are still people on SQL Server 2005, 2008, R2, 12, 14, etc.
Normally we do a pound, I think.
Sorry,
I was going to go pound and a half.
Still getting a little crosstalk here. But basically, the optimizer gets smarter and smarter and better from versions. So I think the overall messaging is that if you can get your client to upgrade to the newer versions of SQL Server, you're always going to end up in a better performance position than you were in the past because SQL is constantly being updated, especially now once we get into 2017 and now 2019. They're updating them every month with CUs. And so gone are the days where we were waiting 6 months for a soonest pack update. Every month they're putting in new functionality, enhancements, bug fixes, and so their timeline for development is much increased. So I think that's the basic thing. Some of the functions that you may find that are going to be super performance enhancing may only be available in Enterprise. So do your research before making a recommendation or trying to use the functionality because maybe the license that the customer has maybe isn't going to be the right license for you to be able to use the functionality you spent a lot of time Googling.
Azure. Faster if you use a local SQL Server versus Azure. Go ahead and talk about that.
Well, and so depending, right? So Azure SQL database, the database as a service component, it is built on the newest. So Microsoft has basically gone cloud first. So that means every single thing that they develop, they're going to put into Azure SQL DB, let it bake a little bit, and then it'll translate into CUs or new versions of SQL later. Susan, could we maybe mute everybody real quick, and I'll just kind of get through this, and then we'll. So, yeah, Azure SQL is currently on SQL 2019. It's got ADR enabled, which is the accelerated database recovery, which means that queries will roll back immediately. So if you have ever had a query that someone left running for 9 hours and then you kill it, and then it takes another 9 hours to finish rolling back, this is immediate rollbacks in Azure. And else it'll be in 2019 Enterprise. There's just a lot of really great things about being in Azure SQL DB, but there's a lot of drawbacks as well. Things don't exist there. So there are some stored procs, system stored procedures. There are some functions. There are some, everything's in UTC. There's just a lot of little things. You have to do a lot of research before you just put your database out in Azure from on-prem and go, oh, it's done. A lot of your code may just stop working. So it's just, I'd love it. I have a client that has 100 databases in there, 14 terabytes of data. It's a massive undertaking, but it works very well because they went into it knowing all of the little things that could bite them, and we just coded around them. But I like all of the on-prem VMs in Azure, Azure SQL DB. They all have their place, and it's just picking the right version. And from a cost perspective, you really can't beat going into that as opposed to buying multiple cores of enterprise, So it really depends on budgeting and all kinds of things. But yeah, from a performance perspective, you probably get the bleeding edge on Azure, and then later on it would translate into new versions of on. Yeah, Greg was mentioning binding for scalar functions. So scalar functions have always been, they're single-threaded, they're row by row, and in SQL 2019, they've done some rewrites to make scalar functions work better, but in certain scenarios, they're still going to be row by row and kind of slow. But yeah, we try to stay away from scalar functions when we can. One trick, now that we have just a minute left, one trick that I did notice is some of our developers will put the get date down in your code set, in your where clause, in your join, in somewhere. If you have the opportunity to use variables to write your code, I always try to write that declare a date time type at the very top, and then put the get date at the top in your declare of your variable, and then use that variable down below. It'll turn your query from a row by row function call on that get date into a one-time call at the very top when you're declaring it, and then it'll just use that value in the rest of your code. So if you've ever seen something like that happen, try putting your date time or your function at the top in a declare, if you're not going to have to run every record through it like an actual scalar function.
Oh, that's a great tip. Thank you.
Yeah.
All right. So good. Thank you so much, Jacob. We appreciate it. Looks like everybody was super happy with this. Again, we're going to have the recording here in a few days, along with the link to the revised PowerPoint. If you want to reach Jacob, what's the best way to reach you, Jacob?
Let's see. It's Jacob. I always forget if it's Jacob G or Jacob. Let me just double check here. Jacob G at itimpact.com.
All right. So thanks everyone for being here, and you can reach me at jsoto@itimpact.com. And Jacob is available, so if you'd like to hire him as a consultant through IT Impact, little plug here for the company, is available. And we will see you again next March, where we'll have another great presentation. Still don't have a topic for that, but I welcome any feedback on that. So let me know on LinkedIn. If you're not a member of our LinkedIn group, search for Access with SQL Server LinkedIn group and manage that group. It's a private group. Just request membership, and for the most part, we'll grant it. And you can also reach me at Twitter at jsoto22. And thank you very much for Susan. Always great to have a coordinator to help us with these meetings. And for everyone that showed up. So long, everyone. Have a great evening.